Okay, so getting into our next chapter, chapter 7. Chapter 7 is on what's called algebraic expressions. Okay, so we'll get into a little bit of that, but first of all, I know we've talked about this before, but it is something that just a little refresher for you. Remember, you have two things that are usually people confuse them and link them together, but and they are linked together, but they are different. And that is expressions and equations. Okay. Now, guys, root word for an equation is what? Talked about it. What's the one root word that's within the word equation? Equal, right? That is a hint that an equation has an equal sign. Okay? It's just one easy way of remembering it. An expression, however, doesn't have an equal sign. As a matter of fact, an expression, it doesn't have an equal sign, but you can almost think of it as being like half of the equation, like something that would go on one side of the equal sign. That would be an expression. Okay? Now, when you start talking about algebraic expressions, you're talking about expressions that have letters in them, variables. Okay? So, the reason why I'm kind of leading up to this is because our very first lesson is on a property. Okay? And you probably have learned about properties, heard of commutative property, associative property, okay, both of addition, multiplication, maybe identity property, stuff like that in elementary school. Okay? Distributive property, though, is mainly closely linked to 7th grade because it's closely linked to algebraic algebraic expressions, which have variables. Now, with algebraic expressions, okay, just a little thing, we actually, this was an actual vocab word in the Math 7 book, and I thought it was a really good one, and that was simplest form. Well, you guys have heard of simplest form before, right? Put your answer in simplest form. Most of the time, we link that probably with fractions, right? It's like, 2/4 in simplest form, I reduce, it's 1/2, okay? With expressions, it's a little different. There's two things that make an expression in simplest form, or two main things that you'll have to worry about right now, and here they are. One is they can't have something called like terms, and we haven't gotten there yet, but that's one condition. The other condition, it cannot have parentheses. Parentheses should not be in your answer, your simplest form answer. Okay? That's where this comes in. Distributive property is a way to get rid of parentheses. That's kind of its main purpose when we talk about algebraic expressions. Okay? So, what I want to do is we do have two vocab words. Okay? And so here we go. The first vocab word or phrase there is equivalent expressions. Everyone? Equivalent expressions. All right, so your book says these are expressions that have the same value. Expressions that have the same value. So in your little box, here's just an example of two expressions. You don't have to put the brackets, but now you say, well, that's an equation. There's an equal sign. Well, no, it's talking about here's an expression and here's an expression. So this expression here is equivalent to this expression. If you were to simplify them, they would give you the same answer. That's what the equal sign means for the equivalency. Okay? 5 times the sum of 2 plus x is the same as 5 times 2 plus 5 times 4. Did I say that right? 5 times the sum of 2 plus 4. Did I say that?
No, you said x.
I did say x, huh? I'm already thinking algebraically. Yeah. 5 times the sum of 2 plus 4 equals 5 times 2 plus 5 times 4. Okay. Let's go on to our next. And some of these may or may not make sense to you, but by the time we're done with this lesson, you'll see. Okay? Here's the next one. Distributive property. Everyone?
Distributive property.
All right. So first of all, here is the definition that the book gives you. It says to multiply a sum by a number, you multiply each addend by the number outside the parentheses. Okay? Now, believe it or not, this is kind of an example of that. If you saw something like this, where you had two numbers that were added, when you multiply 5 on the outside, it says to multiply a sum, that's the 2 plus 4, by a number, that's the 5, you would multiply each addend, the 2 and the 4, by the number outside the parentheses, by the 5. So the 2 by the 5 and the 4 by the 5. That's what that's talking about. Now, many people say, okay, Mr. Wilkins, that's great and all, but isn't it easier just to say 2 plus 4 is 6, 6 times 5 is 30? Hello? Okay? Instead of doing all this? Well, yeah, but what happens when you have that? Okay? You can't add 4 plus y. All right? We'll get more into detail later on, but the way to get around that is by using distributive property. So that's why we do this. It's a way to get rid of the parentheses when you have a algebraic expression, one with a variable. Okay, here we go. In your little, getting back to distributive property, in your little box there, that's just what I was talking about. To eliminate parentheses when PEMDAS, or the correct order of operations, doesn't work. Okay. Sorry, guys. I just realized there's a typo here. It should be D-I-S-T-R. I mean, it's probably correct in your notes, but I just wanted to make sure I pointed that out. I just realized that. Okay, so those are our 2 vocab words. Let's go ahead and do some problems that have to do with distributive property. All right, so go ahead, grab your book, flip over to page 294. Grab a piece of paper, of course, and put the correct heading on it. First, last name, your period, date, the assignment number. Eyes up here as soon as you're ready to go. You have all that done. Eyes up here. Let's see, you guys are ready. Okay. Here's what I'd like you guys to do. Okay, first off, for this first one, go ahead and put your pencil down. Okay, this is one of those I'm going to do, let you watch, and then I'll give you guys 20 seconds or whatever to copy it down. Okay. Take a look at problem number 4. Okay, and here's what number 4 looks like. It is, in parentheses, it's asking for the sum of 5 and 6, 5 plus 6, and multiply that sum with 8. Now, here's what I want to point out. The directions on that, let's read the directions, by the way, in your book. It says, use the
Distributive
property to write each expression as an
equivalent
numeric expression. Then
evaluate
the expression. Okay, so here's what it's talking about with those fancy words. Okay, now let's get this out of the way. Okay, using mental math, using order of operations, what's the answer to that right there?
88.
Only one person knows that. Okay, 5 plus 6, 11 times 8. Yeah, it's 88. Now, so here's what they do: is the book is designed to start off with some easy problems. So what you're going to do is you're going to use distributive property, because that's what they're telling you to use for practice purposes. And then when you get the answer, you'll be able to check your answer with just going back and using order of operations and checking. Okay. Obviously, if I do distributive property and get something other than 88, I did it wrong. Okay. Now it's going to get more challenging. This is just the very beginning. All right. So here's what distributive property is all about. Okay. I'm going to take this here and multiply it with both numbers or both terms, which we'll get to in a bit in there. Now, some of us will feel more comfortable doing this, moving the 8 to the left. Okay, it works either way, but a lot of times this is a little easier for some people because it kind of goes left to right. And then what I'm going to do is I'm actually going to circle all of my integers. Okay, the reason is because I need to identify them for sign purposes, as well as I don't want to forget any of them, and that is a common mistake. So here's all I do. Okay, remember on this particular one it says write each expression as an equivalent numeric expression. Here's what that's talking about. I'm going to link it by something called what people call the rainbow method. I'm going to take these two, link it together, and I'm going to multiply 8 times the 5. I'm going to write it just like that. Then what I'm going to do is I'm going to put an addition sign here, and I'm going to link the next two. 8 times 6. Okay? By the way, why do you think it's called the rainbow method? Yeah, it appears like a rainbow. And the longer expression you have inside, the more stripes there will be. It'll look a little more like a rainbow. So it's just more of an informal name that people will call it. Okay, so here we go. From here, use an order of operations at this point. This is what they're talking about right here. And then 8 times 5 is 40. 8 times 6 is 48, right? We add them together. 88. Okay? So when it comes to that top section, it says write each expression as an equivalent numeric expression. They're talking about this. And then it goes on, right? It says evaluate the expression. They're talking about all this to get there. So you'll need both of these on that top section to be able to get it right. And of course, like I said, then go back and do a quick 2-second solving of that, and they match. So I probably did it correctly. At least the mathematics correctly. Okay? So I'm not going to let you ask questions right now because we're going to go a step by step on the next problem, but I'm going to go ahead and give you about 20 seconds. Go ahead and write that down really quickly. Okay, that's problem number 4. Get that out of the way. Okay. Anyone need more time on copying that down? Okay, just a few more seconds there. Okay, here we go. Let's go ahead, go to the next page over, just page 295, and let's take a look at problem number 10. Now, number 10 is -4 times the difference of 8 minus 5. Okay, now, with this particular problem, the directions are exactly the same. Okay, so that means I'm going to go about solving this the same way. Now what we'll do is we'll call this, we'll call the first one like step star, not that it's a necessary step on every single problem, but just kind of point some arrows on the right and on the left. And all that is just a reminder that if it's on the right, it's okay to put it on the left. Communitive property, right? It says if you have something like 5 times 4, it's the same as 4 times 5. Meaning if you're multiplying two things together, you get the same answer by switching them. Well, right here, right? This times 8 is the same as 8 times this. Right? That's what allows us to do it. In this case, we don't have to do that. All right, just kind of keep that in mind. That's an option if you want. Okay, we'll call this, of course, step 1, and that is, let's do some circling. Let's identify our terms. In this case, it's going to be our numbers, our integers. So I'm going to circle my -4. I'm going to circle my +8. And I'm going to circle my -5. Make sure you include that negative with the 5. It has a negative value. Now comes step 2. And I'll put the word here, rainbow. All right. And that is, I'm going to use the rainbow method, and I'm going to go ahead and write down an equivalent expression. Okay, what they call, right, an equivalent numeric expression. So here we go. Rainbow is -4 times 8. So I write down -4 times 8. So then in this particular case, I'm going to write plus, and then negative 4 times negative 5. All right, so there's our first part of our answer. And then step 3 is, because it's an expression, we'll use the word simplify. Let's go ahead and simplify this. So don't forget to use order of operations here. Don't be adding the 8 and the negative 4 first. We're going to do the multiplication first. So negative 4 times 8 gives us a negative 32. The negative 4 times negative 5 is 20, positive 20. I go ahead and rewrite it by putting my addition sign. Okay, and of course now I'm going to go ahead and combine those two. So I have a negative 32 plus 20. There's 32 negatives, 20 positives. Okay, that means I would subtract. The difference is 12. Of course, there's more negatives, right? The negative value, absolute value, I should say, is larger, so it ends up being a negative answer. So negative 12. Okay? Questions? All right, here we go. Here's the one I want you guys to try. Problem 12. Problem 12. Go. All right, anyone still working on that problem? Okay, a few more seconds, then I'll let you guys share. Okay, 30 seconds, all right. Guys, when you share with your neighbor, make sure that you guys share both this equivalent numeric expression and then the simplified answer, all right? Share both of them. Okay, 30 seconds. Turn and share, go.
I got 96.
I got 96. I had to change it because I I subtracted out first, so I got 1.
All right, here we go. I'm going to go ahead and do this with you guys, but before I do, I want to check in on your guys' answers to see what you guys got. All right, so what is the answer? That's all I'm looking for right now. Seat number 14. Hernandez? Yeah, you have an answer for seat 14? Okay. Seat 24. 96. Agree, disagree there. What do you guys think? All right. All right. Looks like a majority of you guys, almost all of you guys agree. Anyone have something different they want to share? All right, well, let's check this out. I'm going to go ahead and put my 6 over to the other side. And again, I'm going to use distributive property. So here are my terms, or my numbers: 6, 23, and -7. So the first one I have is 6 times 23. Okay, plus, and then 6 times -7. So when I simplify, I'm going to do my multiplication first. Let's start with a nice easy one. -42 is there. Okay. And I have here, well, I have 6 times 3 is 18. Carry the 1. 6 times 2 is 12. Plus 1 is 13. And now, at this point, right, it's 138, and this is a double sign, meaning it's just a -42. So 138 minus 42 is basically what this is. So if I can go over to the side over here, 138 minus 42. That is 6. You can carry if you want, or you don't have to. Say 13 minus 4 is 9. So we end up with positive 96. Nicely done. Okay, guys, questions on those? All right, let's take it up a notch now. Here we go. Let's go ahead and go to problem number 6. Problem number 6. Okay, now we have a couple of other little things going on. Okay, so number 6 is, it gives us 3/4 times the expression of m plus 8. I'm sorry, m plus 4. M plus 4. Okay. Now, on this, it just says write each expression as an equivalent algebraic expression. Okay? Meaning they just want you to simplify this as far as you can go. We're not going to be able to simplify it all the way down because it doesn't tell us what the variable represents. They didn't define the variable, saying m is equal to 6 or something like that. Okay? So, here we go. I'm going to go ahead and I am going to start by, it's already on the left, right? I'm going to follow the same steps. I'm going to circle my numbers, or in this case, my variable as well. I circle the positive with the 4. Now here's what we're going to do. On these particular problems, I'm actually going to be okay by skipping this step right here. Okay? So, here's what I'm talking about. -3 times, I'm sorry, -3, I don't know where I got -3. 3/4 times m is 3/4 times m, or in this case 3/4 m. That's all we can do. Now comes 3/4 times 4. Now if you want to do it this way, like we did up here, I'm okay with that. It gives you some extra wiggle room to solve it right in a line. If you want to go do a little bit of scratch paper work over here, you can. 3/4 times 4/1. Look at this. Cross cancel, you get 3/1, which is 3. So is it positive or negative? We can actually take the positive sign, have it double up as an addition sign, plus 3. Because of the m, we can't add those. Okay? So, that is our final answer. So a couple of differences here. Okay, one is we have a variable. Okay? Second thing is we have a fraction. All right? But there's nothing there I did that you guys can't handle. All right? The process is still the same. I'll make it a little easier on one of these where you don't have to do this middle part unless you want to. Like I said, you could have done this right here in the middle and been able to still simplify. Okay? So, like I said, same steps apply. Even though it was a little more challenging, I didn't write any new steps because they're exactly the same steps. All right, questions? No. Do not convert it to a decimal. I want you guys, if it's a fraction, please keep it as a fraction. If it's a decimal, keep it as a decimal. Okay? You will see both in here. Okay, in this lesson. You need to be good at both. So you need to practice at both. Okay? All right. Good question, though. I'm glad you asked it. All right. Any other questions, guys? All right. I want you guys to try out problem 18. 18. Go. All right, how many of you guys are still working on it? Okay, checking in another 20, 30 seconds. Okay. Okay. 30 seconds. All right. Go ahead and share what you have. Go.
I got negative 74 plus negative 7.48.
Yeah, negative 7.48. Oh, I put the
All right. Problem 18 was negative 7 4/10 times the sum of 10 and a, 10 plus a. Okay, so just checking in on some of your guys' answers. Here we go. Seat 35.
I got negative 7.4a plus 74.
Negative 7.4a plus 74?
Yeah.
Plus 74. Okay, agree, disagree. What do you guys think? Let me say that one more time because I have some people kind of looking around. The answer, negative 7.4a plus 74. Agree, disagree. Okay, some agreements, a few disagreements. All right, kind of split there. All right. Anyone want to share a different answer? A different answer, John?
Negative 74 plus negative 7. Negative 74 plus negative 7.4a.
Okay. What I want you guys to do, especially because this is an advanced class, okay, I want you guys to start getting used to getting rid of the double signs. Okay, there's no need. So, for example, this right here would be equivalent to negative 74. A plus negative is the same thing as a subtraction sign, minus 7.4a. Okay. Now, for the sake of this problem, I'll take either one of those for right now. So how many of you basically agree or disagree with, either one of those are fine. So agree, disagree now. Okay, now all of a sudden we've got a lot of more agreements, okay? Well, let's check this out here. Okay, if I go through and do exactly what I showed you guys how to do, step 1 is, well, step star we don't have to do, but step 1, I'm going to circle each number or term. So it's a negative 7.4, a positive 10, in this case a positive a. Now I'm going to multiply negative 7.4 times 10. Well, if you're multiplying by a power of 10, all you're doing is moving a decimal. So 7, not the negative, but 7.4 times 10 is just 74. Just move it over one time. Okay, if you use a calculator, that's fine. I have a negative times a positive, so of course that's a negative 74. Now, negative 7.4 times a is negative 7.4 times a. I'm going to write it just like this. Negative 7.4, negative 7 and 4 tenths times a, or negative 7 and 4 tenths a, or negative 74 minus 7 and 4 tenths a. And there you go. Okay, questions?
What if you put negative 7? What if you just switched it? So where the negative 74 is, but 7.
Okay, so we have not gotten deep into equivalent expressions. We've not gotten into what things called like terms, and we haven't discussed. This is the first lesson in this chapter. Okay. However, do know this. You see how I circle these like this? Some of you guys, we obviously are circling them to kind of link it together, to organize it. There's a lot of different reasons why I'm having you do this. But what I'm doing actually is I'm getting you also prepared for being able to identify terms. Okay, we haven't talked about terms yet. Now, what that means is if I was to, I'll just kind of like put a little red dotted line around these two. If I was to have you do it, you would probably circle them like this. Those are two different terms. Now here's the neat thing about terms. You can actually flip-flop them as long as the sign stays the same. What that means is this negative, or this subtraction sign is a negative 7.4a. You can put that, but you've got to bring the negative out with it, negative 7.4a. Then my negative 74 goes behind it as a minus 74. This is an equivalent expression to that. As a matter of fact, as we get deeper into this chapter, that is a better answer, and that's what your teachers will ask from you as you go into 8th grade and into high school. Because when you usually label them, it's usually in powers with the variables, and on top of that, so it basically, if it's a variable, it goes to the left. If it's what's called a constant, meaning just a number, it goes on the right. Okay. I'm not going to be too picky about this. We're already learning distributive property, so during this chapter or during this lesson, I'm not going to worry about it right now. But just kind of to introduce you, that is the same as that. Both of them are okay. You'll need to be aware of that when we correct our homework on Monday too. Okay. Any other questions on that one? I do not want double signs. So if you got a double sign, correct it now. Okay. It's not the end of the world right this second, right? But make sure I want you guys to be aware. I want single signs. No more double signs. Okay? That's elementary stuff, elementary school stuff. And it's not a bad thing because a lot of times it helps you with the concept, with the idea, but you need to make sure they're simplified. And this is what you're going to see in your books on tests, on the state test, and everything else. Okay, if it does pop up, you still need to be aware that those two are the same. Okay, because every once in a while it might pop up like that. But yeah, that's what we're looking at. Okay, now let's go on 295. Let's take a look at problem number 16. Okay, on 295, number 16. Okay, it is a word problem. So here is what we're going to do. Okay, some of these word problems are actually asking you to, I mean, if I had you raise your hand and say, guys, how many of you love doing mental math? Okay, most of you guys, of course, would raise your hand. Okay, mental math, when used correctly, can be an extremely powerful tool. This right here is being able to use distributive property to assist you on how to do strategic mental math with big problems. Okay? It can be used on all problems, but on some problems it can. Okay? So here's what you're going to do. All right? Let's go ahead and close read this problem here. Here we go. Martine bought 2 pairs of jeans that are on sale for $32.85 each. Use mental math to find the total cost of the jeans. Justify your answer by using the distributive property. Now, here's what you're going to do. Okay? First of all, okay, we're not talking about percentages or taxes or total cost versus discount or on sale. Don't get that confused with our last chapter, okay? It's just saying each pair of jeans are selling for $32.85 each, okay? He's going to buy 2 of them. Now listen, you can even say this as step 1. And I'll put like a little, let's kind of make it look like a little brain. What about that? I don't know how that looks like a little brain, but you know, a little brain stem to it, okay? But this is mental math, all right? How would you solve this problem if you were just going to use a calculator or paper? How would you do it? Well, I would do it as 2 times, right? 2 times 32.85. Now, some of us, especially because that's a 2, could actually go, okay, 2 times 5, 2 times 8, and carry. Okay, you probably can kind of do it as mental math, but that's not the kind of mental math they're talking about. Okay, here's what it means. I have an idea of what I would do. What I'm going to do is I'm going to take the more complicated number, and this is step 2. I'm going to take the more complicated number, and I'm going to simplify it. Okay? And what I mean by that is I'm going to like expand it. And I could even write that here as a step. I'm going to expand that number as an expression. Okay, you could write expression instead of expand if you want. And what that means is, and this might seem a little weird, but this is a great way to do strategic math. Watch. I can expand this by doing it 2 ways. I can say this is $32 plus 85 cents, or I could say it's $33 minus 15 cents. Either way would work. I'm going to do it this way. And you might be saying, okay, Mr. Wilkins, you're making it more challenging. Okay? No. Watch. I still have my 2, right? Now, step 3. I'm going to put DP here. I'm going to use distributive property. So, two times 33 is what? 66. What's 2 times 15 cents? In this case, it's a negative 30 cents. Step 4, simplify. Guys, what's $66 minus 30 cents? $65.70. Now listen, it says to do mental math, solve it using mental math, and then justify. Well, we kind of did it backwards, and that's okay. Your work right here is your justification. That's what they're saying. Put your mental math. Now, I'm hoping that you can store those things in your head and use mental math strategically and do that mentally. They do want you to show your work. That's your justification, okay, on these problems. Okay? So you just separate 32 and 85 strategically. It's 33 minus 15 cents. So, okay, 2 times 33 is 66. 2 times 15 is 30 cents. So you say, oh, well, $33 minus the $66 minus the 30 cents, and you get your $65.70. Okay. All right, I'm gonna have you guys try one. Ready? Problem number 5. Problem number 5 on page 294. Go. Anyone need more time on that one? Okay, bless you. Okay, 30 seconds, turn to your neighbor. I want you to, you can share your answer, but share your work. That's more important. Share your work. 30 seconds, go.
I got $6.50. First I put 1.30 times 3 plus 2. Then I added 3 plus 2, then got 5. Then I subtracted 30 cents from $1.30 and got this.
I got 6.30, but I saw yours.
Okay, eyes back up here. Here we go. Problem number 5. You purchased 3 blue notebooks and 2 red notebooks. Each notebook costs $1.30. Use mental math to find the total cost of the notebooks. Justify your answer by using the distributive property. So it's very much like the last one. Ladies and gentlemen, the 3 notebooks, 2 red notebooks, if you did them as separate problems, you're making it too hard on yourself. The bottom line is every single one of them costs $1.30. You're talking about price. That is irrelevant information, right? The blue, the red, who cares? Here's the bottom line. 5 notebooks, each $1.30. So here's what I'm thinking. If I was to solve this problem, that's why the little mental step was very important. I would just go 5 times $1.30, right? However, here's how I do it. 5 times $1 plus 30 cents. Using distributive property, 5 times 1 is $5. And then plus 5 times 30 cents is $1.50. $6.50. Okay? Questions on that? Okay. I tell you what, let's hold off on questions. Really quickly, I want to explain this before I forget. Take a look at, in your book, problems 25 through 30, as well as 31 through 34. Those are all mental math. You're going to solve them exactly like we solved these 2 word problems. They're like the word problems, they're just easier because they're not word problems. So you're going to take the more complicated number. For example, number 31, 4 1/5 times 5. You would just say 5 times 4 plus 5 times 1/5. Okay? But you'll have to justify it by showing your work. So it is mental math, but you're still justifying it by showing your work. Okay? Distributive property, ladies.